Why do electrical grounding codes evolve so frequently? Imagine plugging in a device and wondering if it's safe. Electrical grounding is what keeps that safety reliable. But have you ever noticed how grounding rules seem to change often? That's because the world of electrical systems is always moving forward. New technology, safety lessons, and better understanding of how electricity behaves all push these codes to update regularly. Grounding is simply connecting parts of an electrical system to the earth. This creates a stable reference point for voltage and gives fault currents a safe path back to the source. When a fault happens, like a short circuit, grounding helps protect people from shocks and prevents damage to equipment. As electrical systems grow more complex and sensitive, grounding requirements must be refined to keep everything safe and working properly. One big reason codes change so often is technological progress. New devices like ground fault circuit interrupters and arc fault circuit interrupters are designed to detect dangerous faults quickly. Codes need to specify how grounding supports these devices so they can do their job. For example, GFCS are used in bathrooms and outdoor outlets to prevent shocks, and they relying on proper grounding to work correctly. Safety lessons from past accidents also influence code updates. Failures caused by faulty wiring or defective equipment have shown where grounding practices need to improve. Stricter bonding and grounding rules are added to reduce the chance of shocks or failures. These lessons help prevent similar incidents in the future. Our understanding of how electrical systems behave has grown too. Engineers now know more about how grounding affects system voltages, transient conditions, and fault clearing times. This knowledge leads to changes in conductor sizes, electrode requirements, and bonding methods. For example, grounding conductors must be sized based on the size of the overcurrent protection device, ensuring they can carry fault currents safely. Building designs are also changing. Modern buildings have more electronic equipment and sensitive devices. To reduce electromagnetic interference and keep signals stable, grounding systems are adapted. Codes now specify how to design grounding to minimize noise and interference. Regulatory bodies and industry groups regularly review and revise standards. The National Electrical Code, for example, is updated every 3 years through a consensus process involving engineers, safety experts, and industry stakeholders. This process ensures the codes stay current with new technology and safety practices. Different regions might have unique SOL conditions or utility practices. These regional differences lead to specific updates to grounding codes to address local needs. For example, areas with highly conductive soil might requiring different grounding electrode sizes or types. For electrical professionals, staying current with these updates is essential. Using outdated grounding practices can lead to unsafe systems, equipment damage, or code violations. Regular training and review of the latest standards help ensure that systems are safe, reliable, and compliant. In essence, grounding codes change often because technology advances, safety lessons are learned, and our understanding of electrical behavior improves. These updates help keep people safe and electrical systems functioning smoothly in a world that keeps evolving.